Okay, so in this lab here, we're going to be looking at the single replacement reaction between aluminum and an ionic compound called copper 2 chloride. We are going to try to do this a little bit quantitatively here. We're going to measure the mass of the aluminum to start off with. Once the replacement reaction has happened, it should be producing copper as a product. Again, we're going to weigh out what the copper is afterwards and have a look whether it matches up to what we would expect from our mole ratio. In case it doesn't, we'll have to talk about some sort of experimental errors that came into play here. So, starting off here with a piece of aluminum, we do call it tinfoil, but it is just aluminum. This is Al with no charge. I've already zeroed my electronic balance here. I'm just going to weigh my aluminum foil. I know it doesn't weigh a whole lot, but nicely for a 2 decimal place scale here, we can track the mass. So let's record that down as 0.28. 27 is flickering a little bit. If you're doing an error, you can do a plus or minus, let's say 0.01. That's going to be our aluminum. This is the guy that's by himself. We're going to be reacting this one with our ionic compound copper 2 chloride. Copper 2 chloride is currently a solid powder. We're going to make a solution of it first, drop the piece of aluminum into the solution, and then after we've sort of dried and got rid of some of the water, we're going to weigh out the copper 2 chloride, the copper produced from the reaction. So I have the mass of the aluminum here. I do want the mass of the test tube here. You'll see why in a second here. So I'm just going to put the test tube here, just make sure it doesn't roll around. This is the mass of just the empty test tube, so 23.23 grams. Again, plus or minus 0.01. For my copper 2 chloride here, I could theoretically here put the solid on and then weigh the test tube directly. Normally what you can do here, especially for powders here, is you can pull out what's called a weigh boat. Now in fancy labs here you have a plastic little dish called a weigh boat here. I'm just going to use a piece of paper, just fold it into fours here to make it a little bit easier to pour in. I'm just going to put the paper on top first. I know the paper itself is going to have mass. You could totally record this mass down, scoop in the powder, and then do a subtraction, or more simply here, let's just tear the scale. So if I zero it, it forgets the mass of the paper. Anything now I scoop on top of that there, it should be just the paper. Now I see that it's still flickering here, just make sure it's completely zero to begin with. I'm going to take my copper 2 chloride here. It's not going to matter exactly how much I toss in here, but let's just scoop a generous scoopful here. So I'm going to grab some of this powder. You'll notice that it starts off as a brown color powder. So I'm going to scoop a little bit into my weigh boat or onto my piece of paper. Scoop a little bit more just to be sure. It's always okay to grab more from the bottle. If you happen to get too much, let's say the experiment called for 5.5 grams and now we're 5.74, that's fine. You're just going to use 5.74 in your calculations later on. Okay. So our copper 2 chloride is currently here 5.73. I'm going to be transferring this into my test tube here. So I'm going to just carefully pick this up here. We're going to fold it along that sort of middle plane here, and I'm going to see if I can just pour it in. We do want to tap the piece of paper so that any of the powder here drops in completely into the test tube. Okay. Now, although the reaction itself is directly between aluminum and the solid compound, again, what I'm going to do is I'm going to add a little bit of water. I'm going to pre-dissolve this copper 2 chloride so the mixing happens a little bit easier. So I have my copper 2 chloride in there. I just have a beaker of water sitting on the side. We can watch what happens as I make a solution. Maybe I'm going to add water so that I sort of double that volume there. Okay. You notice right away there's a difference in color. We started off here with a brown color powder. As I added water to it here, a characteristic copper 2 ion in solution here appears blue. So as more of this brown powder actually dissolves in, we're actually going to be producing more of the copper 2 ion. We're going to learn transition metal ions are colored in solution because the ligands are causing a split in D shells. Okay, more on that later on. Okay. So I've just made my solution here. This is fairly concentrated. I had quite a bit of powder. I added not too much water there. Okay. You might actually be able to find traces of solid still at the bottom, so you just want to guarantee that the solid is fully dissolved. Okay. And our reaction again is a replacement between this copper 2 chloride and our aluminum. So now our aluminum here, unfortunately here by volume here, it's a little bit too large to toss into a test tube. I can rip it here. That doesn't change the mass of it here. Might even need to fold it into little pieces there so that it can react with the copper 2 chloride a little bit better. So I'm just going to start dropping this in. We can make some qualitative observations. Okay. Let's see, fairly quick reaction. It is fuming away here. That's why I'm doing this here in the fume hood. I do want to eventually react all this aluminum, so I'm just going to steadily drop this in. Okay. So we make some qualitative observations here. We're getting bubbles forming. Okay, you can try to do a balance equation to see if you can figure out what those reactions are. If I actually touch the test tube from the side here, it's actually going to feel really hot. So it's an exothermic reaction for this single replacement. Drop in our last piece of aluminum here. I'm just going to use the stir stick here just to make sure I push down any of the extra aluminum. Make sure it just fully mixes with the copper 2 chloride. Once this reaction has sort of stopped bubbling away here, we're going to decant off the solution. I'm going to try to filter off as much of the water as I can. What I should be left with is just pure copper on the bottom of this test tube here. Once we do a quick flame dry to get rid of any of the leftover moisture, we're going to weigh out this test tube. And as we weigh it out here, I'm going to subtract the mass of the empty test tube, and that should be the mass of just the copper produced in the end. So I'm just going to switch over to do that here. Alright, so the reaction has now finished in the fume hood here. The test tube here is still a little bit warm. Okay, what I'm going to do here is I'm going to dump off as much water as I can first, because I know I had dissolved the powder at first. I don't want to be weighing the water. We're going to do that process of decanting again here. We'll take our glass stir rod here. I'm going to take my glass test tube. I'm going to hold the test tube here against the stir rod. I'm hoping to pour out the solution, let the solution here fall into this waste container here. I'm hoping to trap all the solid precipitate left over in the copper. So let's just do that decanting here. Try to get rid of as much of the moisture as I can. Okay. Get a little bit more. Okay. Definitely there's evidence that this decanting, it's not a perfect filtering kind of system because I'm still seeing a lot of trace copper here on the bottom, but I'm hoping here after I get rid of some of the water and I dry off some of this test tube here, I want to hopefully have just solid chunks of copper left over, and that way we can make a comparison of mass. So I'm just going to do one last check of the decant. I pulled out a Bunsen burner here that we can do a flame dry as well. This is almost looking like a slurry here, so try to get rid of as much of the moisture as I can. We'll do a quick flame dry here just to dry off any of the extra moisture, and we'll figure out how much copper solid that we've left over in this test tube. So I'm just going to strike my Bunsen burner here. Get this decant out of the way here. Okay. I'm going to be holding this test tube here over a Bunsen burner, so I'm going to take a pair of test tube clamps here. I'm going to grab the test tube very carefully. Okay. Again, when I wave it over the Bunsen burner here, you want to keep the open end pointed away from yourself. Okay. Now, if there's a lot of leftover moisture here on the bottom here, it really is going to start sizzling. Okay. So keep moving it around here. I don't want it to develop too much tar on the outside, okay, or sit on the outside. Okay. I do want to heat up all parts of the test tube, so sometimes the moisture is up at the top. You can see some of that condensation forming as well. Okay. And basically by doing this flame dry here, I'm trying to get rid of all the water. If I had the time, I could just actually leave this overnight here to let the rest of the just the evening for it to evaporate off. Okay, but just as a sort of rough comparison here, I'm just trying to heat off some of that moisture. Okay. And that way we'll hopefully have just pure solid copper left over in this test tube. We had weighed out this test tube here prior. See some of that moisture left over. I don't want to have the mass of the water interfering when I make one last mass measurement. When you did the single replacement reaction here, we saw it sort of bubbling away. It got really hot. Okay. That was probably just because the reaction is so exothermic here, it actually caused some of the water to boil. So I'm just going to let that heat for a while, and then what we're going to do is we're going to flip back, and then we're going to have a look at what the mass is once everything is dried. Okay. So see you in a second. So this is back to the electronic balance here. I brought over the container that I decanted here, so you can make some observations of how much leftover copper that we weren't able to filter off. I just finished doing the flame dry here. This one, even by eye, looks fairly dry. Right. It's still going to be very hot right after you do the flame dry, so I've left it for a couple minutes here. Once you're sure that it's cooled down, again, what I'm going to do is I'm going to re-zero the scale. And I'm just going to gently put this here over the top of the scale here. Because the copper here is a solid, I'm not worried about it going out. And this is one last mass measurement we need to take here, which is 24.61 grams. That way you can compare how much aluminum mass you started off with compared to how much copper that we've left over. Remember to subtract the mass of the empty test tube first. Thanks, guys.